Hey, Mr. Worst here again. So Act 2, Day 12. We're doing some review on decimal binary stuff because binary is robot math. And we're doing digital systems now, like sort of like a 30,000 foot view of digital systems. It's really nice to know binary going into it. Just kind of like, counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Be really good if you're like 0, 1, 1, 0, 1, 1, 1, 0, 0. You just got it. Okay. And it, my goal is for this not to be um, painful, but to be enjoyable and for you to learn some stuff. Okay, so take off my glasses here. See Mr. Worst without his glasses on. It's funny because I need them, but I said that was reflection. It kind of bugs me. So number 1 says convert decimal 9 into binary. Okay, so you're going to be converting some decimal numbers into binary numbers. And you'll see here, for each one, I listed off all of the binary bit sequences that use 4 bits of data. So that's kind of, those are a lot of words. So things we learned last class. Okay, so hopefully this is a review. Hopefully I'm not scaring you. If you're scared, call me to your breakout room and we'll talk and I'll put you at ease. If you're scared, it's because I'm miscommunicating. Okay. So I want to give you some examples of how to do this. I made some in a Jamboard over here. So decimal to binary. Okay, here's some examples. Decimal to binary. So if you remember from Act 1 and also last class, you can think of the place values in binary as starting with 1 and just doubling each time. So we got the 1's place, the 2's place, the 4's place, the 8's place. And then it goes on and on and on, just like decimal does. There's more places. I'm just going to have us focus, though, on the first nibble of data here. So, and side note, nibble is a technical term. Nibble means 4 bits, okay? 2 nibbles is a byte. Yeah, they're eating metaphor, analogy, what is it? Terminology? I don't know. Anyways, let's take a nibble. So if we have decimal 10, how do we convert that into binary over here? Mr. Larkins had a really good way of describing this other day. Him and I were talking in class. We were helping a student. And he said, hey, what you do is you go to the first bit that's too big. So we're trying to make 5. We go along here. Okay, 1 is smaller than 5, 2 is smaller than 5, 4 smaller than 5. Oh, 8's bigger than 5. Okay, so we're not going to use 8. We'll make that one a 0. But we can use 4. Okay, so 4. Right now we have 4. 4 plus 2 would be 6. That's too many. So let's put a 0 there. So 4 plus 1. Oh, 4 plus 1 equals 5. Okay, so this is the binary equivalent of 5. And hopefully that makes sense. You're just thinking of what things you want to add together up here to make this number over here. Let's do it again. Let's make 3. Okay, so let's see. 8's too big. 4's too big. Oh, but 2, that would work. Okay, so 2 plus 1 is 3. Look at that. 2 plus 1 is 3. Okay, and so I should be more specific here what I'm talking about. Shouldn't just imagine. So this place down here is worth 2. This place is worth 1. So the 4's place was too big. So the first place I used was the 2's place. So I turned that bit on by making it 1. Remember, we learned on is 1, off is 0. And we also turned on the 1 bit. So 1, or not 1 plus 1. The 2 bit plus the 1 bit makes 3. So there you go. Okay, and 11. Oh, I'm almost out of time. Oh no, Mr. Words, he's almost out of time. Okay, let's do the last one here. Hopefully we have time. So 11. Okay, so I can use the 8 bit. So if I have 8 plus 3 would make 11. There we go. So because I have, let's see if I have time. Oh no, it's covering it up. Okay, so this one's worth 8, this is worth 2, and this one's worth 1. See up here? So 8